You covered a lot of ground in this section 6.2. I want to add in a video here at the end to pull some things together, and I want to start right here. I'm at the 7th objective. I'm on page 386, and we're going to be looking for values, evaluating. And I put a smiley face because I like what happens. It makes sense. It pulls everything together, and it's, well, I'll just get started. I'm going to start right here at this theorem. Up here at the top, it is just saying, hey, we have been working on this for a unit circle, but the world is not a cute little unit circle. We got to make it for everything. To do that, we're going to have to back out of this and look at y's, x's, and r's. You know Pythagorean, if you know x and y, you can calculate r. And with all of these pieces, we can pull this together for any angle that you and I are going to look at this semester. The thing that I would encourage you to do is basically to learn everything, but then to start finding what you really like and what makes most sense to you. This entire time, the author of the book has been showing you how to use the unit circle and to generate your 6 trig functions using the unit circle. When we get to the very end, it starts to say, okay, there is another way, but you need to know both, and so here we go. Looking at this theorem, it starts to mention the x and y's and r's, and you see this. What he had mentioned earlier is that sine is y. Well, that's on the cute unit circle where the r is 1. And then in what he was talking about, cosine's x. Well, that again was where the cute unit circle and the r was 1. And so it still works that y over r would be y over 1, and so it still works on the unit circle that it would be y. But to broaden this, we're going to, and what I was taught in college was SOHCAHTOA. And SOHCAHTOA is a way to find the first 3 of our trig identities, or trig functions, and then we can use the 3 that we know, do their reciprocals, and we'll have all 6 of them. So a quick explanation of this. So means that sine of our angle is going to be the opposite side over the hypotenuse. And if you're looking at the drawing, and this is my angle, across or opposite from that is going to be my y, which it all ties together that y is the sine, y over the r. Wait, r, hypotenuse. Hypotenuse is going to be the r. Hypotenuse is always going to be the r. It's always the hypotenuse. The adjacents and opposites are going to flip-flop between x and y, depending on which angle we're talking about. So something you may want to memorize is SOHCAHTOA. Sine is opposite over hypotenuse. That's where we're getting that acronym SO. So then ka is cosine of the theta. Ka is going to be adjacent over hypotenuse. HYP. There you go. Meaning if my angle is here, the side that is beside it, that's what adjacent means, the side that's beside it is x, and so it'll be x for the adjacent over the hypotenuse. I probably should write these in. It'll be y over r. This one's going to be x over r. And then finally, TOA. TOA is going to be representing tangent, and tangent's going to be opposite over adjacent, opposite over adjacent. And everything you've been looking at, every time he would mention tangent, he was saying it's y over x. It is y over x. So this is another way to look at the unit circle, the trig functions, and you'll hear me refer back to SOHCAHTOA. This is the one that makes most sense in my mind, but I'm going to share all of these with you. I would learn all of them and then start to pick which ones you like best to solve our trig problems. And so the theorem right here has everything that we just talked about, except it then goes into the reciprocals. In other words, cosecant is the reciprocal of sine, and so it's not y over r, it's the reciprocal. It'll be r over y, as you see right there, with the understanding that y cannot be 0 or we're undefined. Cosine's reciprocal is secant, so I'll take cosine, reciprocate it, and I get r over x, but again, the x can't be 0 or it's undefined. And then for cotangent and tangent, I'll take tangent, do its reciprocal, get x over r, and then that gets us cotangent. With this in mind, I'd like to do example 12. And on example 12, it is asking us to find the exact values. And I've mentioned this in an earlier video, exact versus an estimate. And it's going to bounce back and forth in your homework. It'll bounce back and forth in on your test. And this one wants exact, so I'm going to highlight that for myself. They want all 6 of the functions, sine, cosine, tangent, secant, cosecant, cotangent, of this angle that is at this negative, or 4, negative 3. So 1, 2, 3, 4. 1, 2, 3, 4, negative 3. So the point is here. So we are talking about this triangle, 4, negative 3. This side is 4, this side is negative 3, and this is going to be our theta. And they want all 6 trig functions of that theta. I'm going to go back to so, ka, toa. I'm going to go back up to the top of the page where it says, hey, remember, x squared plus y squared equals r squared, or it's going to be our hypotenuse squared. So I'm going to start there. To get my hypotenuse, which is going to be r squared, I'm going to need to square my x value, square my y value. So r squared is 16 plus 9, r squared is 25. I don't want r, I want the square root of both sides, so I need that it's plus or minus 5. But when we're dealing with a hypotenuse, when we're dealing with this line over here, this side, it's always going to be positive. Our x and our y can be positive or negative, but our hypotenuse will always be positive. And I get more lazy on this. I'll usually just say my r is worth and start with the square root of the x value squared, the y value squared, and then that just takes me straight to my 5. So our hypotenuse is 5. Once we've calculated our hypotenuse, we are ready to roll. And so starting with, and I will always go in this same order, that way I don't miss anybody, my brain has a pattern to follow. Sine is opposite over hypotenuse. Opposite is across, so it's negative 3. The hypotenuse is 5. That one's done. Cosine. Cosine is ka. Adjacent. So the side adjacent to my theta, which is not my hypotenuse, hypotenuse is always the hypotenuse, is 4. So it's 4 adjacent over hypotenuse. That one's done. Tangent. Tangent is toa. It's opposite over adjacent. Tangent will be negative 3/4. It is done. And then I'll start doing my reciprocals, and I'll do them in order. Cosecant theta is sine's reciprocal. And I can write it with the negative in the bottom, the negative in the top, or the negative out in front of the vinculum. Secant. Secant is the reciprocal of cosine, and so it is 5/4. And then cotangent of my theta is the reciprocal of tangent, which it is negative 3/4, so my cotangent is 4 over negative 3, and we are done. Remember, you can stop this video, you can replay it, you can think on it, but you also have your book that you can look at and notice, hey, we match the book. But in this conclusion, I also wanted to go back to example 8. But before I do, I want to go ahead and show you in MyMathLab, which is now called MyLab Math, I'm going to upload into document sharing a fill in the unit circle. I highly, highly, highly recommend that you make yourself memorize the unit circle. And on this unit circle, you would print a couple of blank copies and then even give yourself 5 minutes to fill the whole thing in. Basically, you memorize quadrant 1 and you're done, because then you just adjust the other quadrants based on their signs. And so like here, I'm here at 0 degrees, which is also called 0 radians, and my coordinate here is I go out 1 and I'm here at 0 for my x. And so what we're trying to do over here is put the coordinates so that then I could do, oh yeah, x goes with cosine, y goes with sine. I can play around with it, I can do all sorts of things. This first one is going to be our 30 degrees. And then hopefully you've memorized that 30 degrees is pi over 6. Before I write this one and this one down, I'll go ahead and write. This one would be 45 degrees. You've memorized it's pi over 4. And this one would be 60 degrees, and you've memorized that it's pi over 3. Before I write these three down, I want to show you how I like to see them in my, as he said, mind's eye. I'll just go ahead and draw it on. I'll go ahead and turn the page over. And so looking here, if I'm looking at a 30-degree angle, when I was in geometry, I memorized ratios, and those are my favorite go-tos. And if my theta is a 30-degree angle, every time the opposite side is going to be 1. Every time the adjacent side will be square root of 3, and every time the hypotenuse is going to be 2. That's every time. And with this in mind, that's how I like to picture my coordinates. Remember, the x-coordinate is going to be related to cosine, and the y-coordinate is going to be related to sine. And I can even go back to my SOHCAHTOA. Sine is going to be opposite over adjacent. And then cosine is going to be adjacent. Sorry, I think I just said that wrong. My sine is going to be opposite over hypotenuse, and my cosine is going to be adjacent over hypotenuse. So my x value is going to be square root of 3 over 2. So over here on my 30, it's going to be square root of 3 over 2, and it's positive because we're in quadrant 1. My sine is going to be opposite over the hypotenuse, so that coordinate is going to be 1/2. I do encourage you to flat out memorize. 30 degrees, quadrant 1, x and y, done. I'm going to go ahead and look at 60 since we talked about the 30. When I was in geometry, I memorized that if I have a 60-degree angle, always across from it, opposite it, will be square root of 3. See right here, it was beside the 30, but it's across. And here, my 1 is going to be beside the 60, but the square root of 3 is across, and that means my hypotenuse will again be 2. The difference is, when I go back to look at SO and the CA, I won't even worry with the TOA right now, but my sine will be opposite over hypotenuse, which is the same as the cosine over here, the sine over here. My cosine over here is the same as sine over here, and it just helps my brain to see the pattern, so I'll go write the coordinate. My cosine is going to be 1/2, which is positive because I'm in quadrant 1, and then my sine is going to be square root of 3 over 2. Again, I encourage you to just flat out memorize these numbers, but I like to show you multiple ways and hope that something really speaks to you and you want to use it. And the last one I'll talk about is the 45. And when I was in geometry, we learned that for a 45, it's a 1, a 1, and a square root of 2. Every time. And with that being the case, when I go back to SOHCAHTOA, sine is going to be opposite over hypotenuse. So the sine of my 45, and I know you've already seen him do this, but I wanted to just bring it all back around together, is opposite over hypotenuse. And we have learned that we never, ever leave a square root in the denominator, so when we rationalize it, I'll get square root of 2 over 2. That's going to be my y value, that is my sine, so I'll go ahead and put it here. If I really want to be lazy, I know that these are going to be identical, but I'm going to go ahead and assume I didn't see that and go with cosine of 45 is adjacent over hypotenuse, adjacent over hypotenuse, adjacent over hypotenuse. Wow, that looks familiar. I cannot leave a radical in the denominator, so I rationalize my denominator and I get the same thing. And again, if I'd been really lazy a while ago, I would have just rewritten it. And this says it all. I can keep going because this is a 90 degree, this is pi over 2. My coordinate here is 0, up 1. And I would highly encourage you to memorize this whole thing and be able to reproduce it pretty quickly. And the more, like he even said in the videos, the more you work with these, the more you're just going to pick up, oh yeah, 45 is always this, oh yeah, 45, and oh, it's over here, so it's negative, things along those lines. The other thing I'm putting in the document sharing for you is a formula sheet. You're not going to be able to use this on the first test, but this formula sheet is going to prove very valuable in our class as well as your future classes. You will be able to use this on some of our tests, but for right now, you'll hear me refer to it and say, hey, Y'all go write this on your formula card, and this is what I mean. So I am asking you to print 2 pages. 1 page, 2 page. And you'll even notice on one side, there's our beloved unit circle. And so that can help you to even piece together, am I doing all of this right? What's going on? But I wouldn't let it be a substitute for you practicing on this template. I want to end this video by working through one more problem and then getting you to do the other 2. And so I've gone backwards, and I'm now on page 383, and I'm looking at example 8, and it says let's construct a rain gutter. It talks to us about this rain gutter, and it talks about it being 12 inches wide, and you see all the picture over here, the drawing. And after marking the length and then set up an angle unknown, they have an opening and they found the formula. So what they're asking us to do is find the area. Here's the formula for area. Okay, let's plug in 30 degrees for theta. Okay, let's plug in 45. Now let's plug in 60. I'm going to work through it plugging in 30, and I'm going to leave 45 and 60 for you to do. And everything's written out in your book, but I even like to cover it up. And when you see me write in the notes, do this without using your notes, or with using your notes as little as possible. This is what I'm talking about, you trying to work through it by yourself. So I'm going to do the first one and find the area for 30 degrees. I'm going to start that their formula says it's 16 times sine, and you don't have to memorize this formula. This is a word problem. They're handing the formula to us. Our job is to plug and chug. And here we go. I have plugged in my 30 degrees. Now I'm going to chug along. And you also need to know that on your first test, there will be a portion where you don't use your calculator, and there will be a portion where you do use your calculator. So this would be a great portion on the test part where you don't use your calculator. So looking here, I'm going to rewrite the 16. I'm going to go ahead and choose to write it as a fraction. And then I'm going to go look for sine of 30. Well, hang on. I'm going to go off on the side, and I'm going to draw that little drawing I had a while ago, that for my 30-degree angle, I'm always going to have a 1, a square root of 3, and a 2. Okay. And if I'm looking for sine, sine is opposite over adjacent, so there's sine of my 30. Cosine of my 30 is going to be adjacent over hypotenuse. There it is, and here this is. And so now it's just a matter of writing it or simplifying it to what they want us to leave it as, or what MyLab Math wants you to leave it as. For sure, we can take the 16.5 and call that an 8. And we got a square root of 3 over 2, and we could do all sorts of stuff like converting this to 2 over 2, but let's go see what they've got going on. And so what they did is see right here where they had what we have, and they went ahead and called that an 8, but then they distributed their 8. And so on the test, when it says leave it as an exact or leave it as an estimate, then this is where, and I tell students all the time, you get to go back and argue by the answers on your test. If you left it like this and I counted it wrong, you can argue, hey, I simplified. In MyLab Math, it may not let you do that. They went ahead and distributed, and when I multiply these first two together, I do get 4 square root of 3. And when I multiply the 8 and 1, I do get an 8. So I would say that this answer or this answer would be acceptable for an exact answer. But then, when it also is showing us the decimal value, like I said earlier, you got to know how to do it all. You got to know how to leave it exact, and you got to know how to go to approximate. In this class, we are only using scientific calculators. I know the author is using some graphers. We have made the decision that since we are a community college and we're not sure where you're going next, and many of our transfer schools, well, they're all different. Some won't let you use a calculator at all in calculus. Some want you to use the TI-84. It's all over the place, so several of us have chosen to stick with a scientific, and that way we teach you the process, we teach you some strokes on the calculator, we kind of give you a good smattering, and that way depending on where you transfer, you'll be ready to go. So looking at my calculator, I've got to learn how this one works, and so it's 4 times, and when I go to do the square root of 3, this one actually I have to do second square, and it's a 3, and I need to go ahead and close that parentheses, and I like to hit equal and just try to outsmart my calculator before I go ahead and do plus the 8 and hit equals. Depending on where we're asked to round, I'm getting 14 point something, and they chose to round to the hundredths. And so that would be 14.9. The 2 has to rely on the 8. The 8 says bump it up 1, and that's where they're getting the 93 hundredths. Let me look at my notes real fast, and that is all I wanted to show you in this concluding video for section 6.2.